right. Hey, y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. I figured I'd share a worksheet that I was working on making because I think it's important to have kids work on their times tables. So I thought that instead of just having people work on, let's say, all the way out to 10, and no all the way out to 3. So like everything from 0, 1, and 2 and 3 all the way out to 10, and then like add rows as you go or adding columns as you go. I thought, what if we just added rows and columns at the same time? Because sometimes people only go out to 10 by 10, but it is helpful to know more than your 10 times tables. The more you know, the better. And there's sort of a rule of the more you add, the less helpful it is to add another set. Like it's more helpful to know all the way up to 10, but it's not doubly as helpful to know all the way up to 20, I guess. Kind of the law of diminishing returns. But I was thinking, what if you had access to times tables of different sizes of grid? So all the way out to 2 times 2 versus all the way out to 3 and 3, 4 and 4, 5 and 5. And then here I have 6 and 7, 8, 9, and then all the way out to 10. That's as much as will fit on a standard 8.5 by 11 with the size that I made. But of course, if I were to make the grid a little bit smaller, then we could fit even more rows and columns. And I'm thinking about doing that anyways. If you think that having all these different times table sheets would be helpful, I can actually make another version where I go out even further. But I tested it out and all the cells should be the same size. Now, because I have the cells twisted, it kind of looks like they're different sizes, but I did the math on them. It should be all the same for what we're looking at here. So, um, yeah, assuming that they don't change things up when you go to like this versus twisted like that. I don't know. I could be off by a little bit. This one, I mean, it really does kind of look like some of them are not proportional, but they're pretty close. So I'm pretty sure I did the math right. Anyways, I hope that is helpful and that you're able to use it. One thing you could use it for is just for drills, because it's good for kids to just know how to do this, right? So, for instance, if I go here, and that's really, really big, let's make that smaller. So let's do this. And can I flip this? I'm pretty sure I can flip this. I can maybe flip this. Ooh, there it is. Found it. Ha 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 ha. And make that smaller. And bring this up to here. Yeah. So I can show you what you can do with this, and I'll time it, but you can probably see how much time it takes me on YouTube as well. So get an idea of how much time it should take. I don't think I'm gonna necessarily go all out, but I think I'll take it seriously here. So I'm actually gonna get my phone and we'll do a timer here so you can see how long it should take. And if you're able to beat me, let me know in the comments. But I'm gonna reset the time here and we're gonna go for it. Okay. So you want them to be able to just fill it out. And you can either do however many they can get done in a minute if you want to try to keep it under a certain amount of time, or you can time them and just see like, have everybody try to get their own personal best, fill out the entire chart and try to get a better time than they did before. So you can do it either way, but I'm going to do it where I do the entire chart and just see how long it takes versus trying to get as many as you can get done in a minute. And go. 0, 0, 0, 0. That whole first row should be 0 because 0 times anything is 0. Then it's going to be 1 times everything. So it literally just matches the number. Then we're doing our twos, but we're starting with 0. So it's 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Then I do my threes starting with 0. So 0, and then 3, 6, 9, 12, 15. Oh, that's a terrible 15. 18, 21, 24, 27, 30. Then I do my fours starting with 0. 4, 8, 12, 16, 20, 4, 28, 32, 36, 40. Then I do my fives starting with 0. These should be super easy. And actually, you can have students do this row and skip some of the other ones they might not be as familiar with. You can do some of the rows that you're better at first, because some of the latter ones, like between 6 and 9, so those are going to be some of the harder ones. 12, 18, 24, 30, 36, 42, 48, 50. Nope, I almost want to say 56 there. That one I do mess up occasionally. 0, then we're going by 7. Sevens might be the hardest one out of all of them. At least I think so. 42, 49. There's the 56. And then 63, and then 70. Then we have our 8s, 8, 16, 24, 32, 40. The reason why I don't think 8s are as hard is because there's a nicer pattern to them. So then there's that. 64? Yes. I need to stop talking and doing things at the same time. I am not good at multitasking. 9, 18, 27. I don't think this one's as hard because the nice thing with nines is that the tens digit goes up and the ones digit goes down. 45, 54, 63, 72, 81, 90. And then the tens should be the easiest one of all. 50, 60, 70, 80, 90, 100. There it is. Okay, so that took me 2 minutes and 30 seconds. So that is the time to beat. And I'm a competitive person. So if you're able to beat 230, which I think somebody should be able to beat 230, because I really don't think I was going all out, because I'm also trying to like say things while I'm doing it. I wasn't completely focused, and I'm like shooting the video while I'm doing this. But if somebody's able to beat 230, let me know in the comments, and I will be up for the challenge and try to beat you beating me. So we'll see how low we can go. Maybe even get the whole thing done in under a minute. But if you're having kids do this, I wouldn't expect kids to be able to do this in under a minute, at least not right away. Maybe with some practice, eventually they'd be able to, especially if they're writing super fast. And then it's like, okay, well, can I even read what you wrote at this point? To be fair, I think, like this 5 here, like that's not even a 5, right? So it has to be legible. But other than that, yeah, I think this is a great way to practice times tables and to make it so that they're able to do both multiplication and division in their head better. And that also translates to other things as well, like square roots and squares. If you look at the diagonal there, right, 1, 4, 9, 16, 25. So it translates to a lot of different things. And if you're able to count by certain numbers, then you're adding certain numbers as well. So really, it kind of encompasses more than just multiplication. So it's a great way to practice just all your arithmetic and then beyond that as well. Hopefully that's helpful. I'm going to probably put this resource. I think I'll probably put it on my website, Myers Mathematics. So you can go check that out down below. But I'll probably also put it on Teachers Pay Teachers, and I'll probably just put it on there for free. Eventually, I'll make a kind of a prettied up version of it and maybe list that as well. But this version where I just have like the basic charts and stuff, I'll probably put that on TPT for free. So go check that out, and I'll catch y'all in the next video. Blessings.